In this video, we're going to use the properties of logs to solve some example problems. Question 1. Simplify the following expression. So we've got log base 2 of 8 plus log base 2 of 4. And we can simplify this using the product rule of logs. Product rule of logs is the following. So in this case, we need to go from this side to this side. Therefore, we can simply multiply these two numbers in the brackets. This is what we're going to get. Log 2 8 times 4, and this is equal to log 2 of 32. Of course, the log you can write it without the brackets, although I would recommend writing the brackets as well. So we can simplify this even further. 32 is 2 to the power of 5. And here we can use another property of logs. So when the base and this number is the same, the log is equal to the power of this number. So in this case, so let me write the property to be more clear. So this is equal to b. So in our case, this log will be equal to 5. And this is the answer. Problem 2. Simplify the following expression. Log base 5 of 25 minus log base 5 of 5. This is again pretty straightforward. In this case we need to use the quotient rule. So the quotient rule of logs is the following. So in our case, we've got, again, we're on this side and we can convert it to this side. So in our case, the expression that we have is the following. Log 5 25 over 5. And of course, the term in the brackets is 5, so we get log 5 to the base of 5, and remember the 5 here is to the power of 1, and so whenever this number is the same as this number, the answer to the log is just the power of this number. So in this case, this entire term is simply 1. And this is the answer to question 2. Problem 3. Here we just need to simplify this term. We can start from applying the power rule. So the power rule is the following. So in this case, C is the power of 2, B is the 27, and A is the 3. So in our case, we get the following expression. Now the 2 is in front of, out of the bracket, and we know that 27 is 3 to the power of 3. So in this case, this whole part becomes 3. So this is 2 times 3, and this is equal to 6. And this is the final answer for this question. Question 4. Compute log base 2 of 10 using the change of base formula with base 10. So typically we can compute this one directly with our calculator, but in this case they're asking us to use a specific formula. So in this case, it's a good idea to start from writing the change of base formula. As the name suggests, you can change the base of a log using it. So in this case, we're told that we need to use base 10, so base 10 will be k in this case. Therefore, log base 2 of 10 equals 2. So in our case, big M is 10, and k will be 10 again. Log 10 again. You can, if you want, you don't need to write the brackets, but it's a good idea to keep them. Log, the base is the same, it's again 10, but in this case it is 2 in the bracket. So this is base 10 of 10, and 10 is to the power of 1, therefore this is equal to 1. And when it comes to the term in the denominator, you can compute this using your calculator. So we've applied the formula, and typically in an exam you shouldn't remember exactly what the value of this is. You probably will have a calculator if they make you do such a calculation. So this expression simplifies to the following: log 10 of 2. And we can use our calculator to see what log 2 of base 10 is. So this is equal to about 1 over 0.301. And this is roughly equal to 3.32. So this is how you use the change of base formula. Question 5. Simplify the following expression: log 64 of base 4 minus 2 log 2 of base 4. So in this case we need to use a few of the properties that we've used already. Why not give it a try, and then I'll do it myself. Now, it's a good idea to start from each term separately. For example, for the first term, we know that 64 is 4 to the power of 3. So for now, and of course this is equal to 3. So this part of the expression is as simplified as we can get it to. About this side, we need to use the change of base formula. So this can be rewritten the following way. Where we've decided to change the base to 2. Now it's 4, and now it becomes 2. You can look up the equation that it was used previously if you want to see the full equation. But yeah, in this case, these two sides are equal, and of course this is the term in the brackets here is to the power of 1, so at the top we've got 1. Here it's 4 is equal to 2 to the power of 2, so it's equal to 2. And the base is 2, so the whole part in the denominator is 2. And at the end of the day, we get a half. But of course, all this is multiplied by the 2 over here. So we get 2 multiplied by half. And all this is equal to 1. And so now that we've simplified both sides, it's as easy as just writing 3 minus 1. And this is equal to 2. And this is the answer. Question 6. We just need to simplify this expression. And why not give it a try? And I'll be the one to solve it for you. So now we can see that we can rewrite these the following way. 81 is 3 to the power of 4. Nine is 3 to the power of 2. And 27 is 3 to the power of 3. So in this case, you see the base is the same as the number in the brackets. So this is simply equal to 4 plus 2 minus 3. This is 6 minus 3 equals to 3. This is the answer. No new properties were used. Just simply there was more terms in this one. Question 7. Solve for x in the following equation. So we're given the equation, and when you see the equation, your first thought should be how you can simplify this. And we can do this using the product rule. Now, there's a trick we can apply. We can put both sides to be the powers of 2. So what I mean is, let's say that we have a 2 here and a 2 here. So this is 2 to the power of log base 2 x multiplied to x minus 2. And on this side it's 2 to the power of 3. And whenever you have this case, whenever this number is the same as the base of the log in the power, the log disappears and you get just this part that's in the brackets. So what I'm saying is that this whole expression is equal to x minus 2, and on this side we keep the 2, so it is 2 to the power 3. And of course this is 8. Now that we have simplified it, we can expand the bracket on this side and we'll get a quadratic equation. And when we move the 8 to this side, we get minus 8. And all this is equal to 0. Of course, you probably know how to solve quadratic equations, but in this case, you can simplify this expression in the following way. So of course, for a quadratic equation, you have two solutions. X plus 2 is equal to 0. Here one of the solutions is x equal to 4, and the other solution is when x is equal to minus 3. So these are the two solutions that are possible for this equation, and this is what they asked us to do. Question 8 is to simplify this expression. So why not give it a go and then I'll solve it. You should be able to do this by now. It looks a bit different compared to previous questions, but just give it a second and I'm sure you'll be able to do it. So in this case, we just need to consider the log separately. Just focus on the log that's inside the bracket, ignore the outer one. This log is of course equal to this one, because 32 is 2 to the power 5, and this one is equal to 5. So this whole thing can be rewritten as log base 5, and the thing inside the brackets, it has become 5. And since 5, it's to the power of 1, it's just 5, all of this just becomes 1. Very easy. Okay, so this is from me. I hope this was helpful. If you've enjoyed it, please like and subscribe. And if you'd like me to solve more problems with logs, I would happily do it for you.